What up, dudes? Can you hear my voice? Actually, you know what? I should start it off like this. What's going on, Algebra 2 students? And let's get this party started. Can you hear my voice? Yes, good, awesome. Then let's get this thing started. I actually know where everybody is. Everyone's taking the PSAT right now, or at least half of our classes. So what we're going to do is I'm going to basically cover my lecture today. I'm going to apologize to people taking the PSATs. Yeah, you missed it. But don't worry, I'm going to archive this. And it's going to be pretty easy stuff. We're going to wade into the water here. But here's what I need to let you guys know. So first thing is, this isn't a Part A and Part B course. It's actually a Semester 1 and Semester 2. So all of the stuff that you have from Quarter 1 is still up there. So your class is going to look huge. So what I'm probably going to do is what I would do if I were you is I would close all of these tabs just to, I don't know, as a hint, all right? I'm just trying to make life easier for you. So I would close all of the Quarter 1 tabs because apparently I opened up everything until today. And then after today, no longer open. It's been open all week, all break, all weekends, 2 weekends, and a whole week of school, or a whole week's worth of school. So, the stuff you turn in today is the stuff you're going to get in. That's it. So from now on, I am not going to open up anything from Quarter 1. I think that that's fair. All right. Quarter 2, I kind of want to give you folks a heads up as to what's kind of coming up. We're going to finish off functions today, or not today, but we're going to finish off functions. So we're going to do functions 4 through, I think, 11 or something like that. And then we're going to move into polynomials. Actually, so it's functions 4 to 10. And then we're going to move in polynomials. So those are pretty cool. I think that one of the changes that I'm making is I'm giving you folks 5 attempts instead of 3, my normal 3 attempts. And I'm making the due date 2 weeks instead of a week after. Or not the due date, but the close date. So it's due, and then, yes, I'll accept it late. But after the thing closes, I don't open them up anymore. That is going to have to finish. The other thing I'm going to do is, to be honest with you, I'm really going to refrain from pushing things back, pushing assignments back. The reason being is because it's kind of causes to get a little bit behind. And we need to get through a certain amount of material by a certain date. So I can't be pushing assignments back. But after Quarter 1, I feel like you guys don't really have an excuse of not knowing how how things work and how my style is. So you should be able to kind of get everything in on time. Is that fair?
Yeah.
All right. So, Bradley, I have no idea why you keep disconnecting. I truly apologize. Let's move on. So, what I'm going to do is we're going to cover functions 4, and there's some archive videos that you guys can watch. I think what I'll do is I'll make it into a quiz where you guys can watch the things. Did you watch this? Yes, I did. And do this. These are recordings I did last year. So if you want a different, maybe not even a different perspective, it might be the same thing I'm presenting today, but maybe me presenting it to a different group of students, that might help you out if you get confused with what we're doing. But anyway, I'm going to cover functions for you today. Why isn't there any homework assigned for Chapter 4? Well, because I think Chapter 4 is stupid. But it still needs to be covered. So at least I know that you've seen it. So that's what we're going to do. Your obligation to functions 4 is to watch the videos and listen to me talk about it. No homework. That's it. Your first homework assignment is actually on functions 5, which is also kind of a weird chapter or a weird section. And so I don't really have a homework assignment where you type in you type in your numbers or whatever, you calculate things. It's more of a note-taking assignment, and we're going to go through that. It's actually going to be pretty straightforward. And today my goal is to get through functions 4 and 5 by the end of today. And that's it. Function 6 we'll cover on Monday. Sound good? All right. Any questions, comments, vomits, concerns, etc.? All right. Then let's get started on functions 4. Okay, I'm going to open. Goes back. All right, so we're getting back into functions, and over here, this is the way we write down functions. This is f times x. Everyone agree? No, it's not f times x. We talked about that before, back when we covered functions 3, way back when. This means f of x. It means the function is a function of x. It is an expression that depends on the variable x. Does that make sense to you?
Can you write it like f and then 0 and then x?
Are you asking, can I write this? f0x.
Yeah.
Fox?
Well, no, it's like f of x.
Okay.
Instead of
the reason why I want to refrain from that is because we're actually going to use this later on.
Oh, okay.
And that it means something very similar but different. So I'm going to refrain from that because nobody else writes f0g, x, or fox, as in f of x. But that is how you read it. It's a function that is of x. Does that make sense to you?
Mm-hmm.
So, for this thing right here, let's see if I can make this so that we can share the screen. Halfway there. I know you guys can't really see that computer screen too well, but let's do it like this. Halfway there. All right. So f of x apparently is equal to negative 1/2 x squared plus 5x minus 8. And we know this is apparently a parabola, right? This isn't anything new. This is a parabola, and this is in standard form. If we wanted to write it in factored form, we can do this. I'm just that good at writing things in factored form, and then if we wanted to graph it, we can always graph it like this. This would be crossing at 2. This is crossing at 8. So 2, 3, 4, 5, 6, 7, 8. Right here, right here. I think it's going upside down. The problem looks something like that. Agreed? That's the wrong factored form. Oh, oops. Yeah, sorry. No, that's what they said the answer was. I didn't actually do it in my head. I just
slapped it on.
Well, I just did it. All right, fine. I'll do it the real way. I won't actually just copy down their answer. Negative 1/2 x squared plus 5x minus 8. That doesn't have to do with what we're covering. I just want to prove to Bradley that I know how to do math. Negative 1/2 x squared minus 10x plus 16. I factored out a negative 1/2 out of everything. And then this becomes x and an x. 8 and 2 would do it. So an 8 and a 2 and a minus and a minus. That's the factored part of that part. And then I still have my negative 1/2 out in front. Done! Ha! I know how to do math. Okay. Yes, you can write it like that. And you can graph it. But really, the whole point of me talking about this was for that f of x little kind of bit right there. Cool? All right. So if I have some kind of graph, and not all graphs are parabolas. We can look at some funky graph like this. Actually, you know what? I draw a horrible graph. Why don't we just look at their graph? Okay, let's make it bigger. All right. So here's their graph, and what they want to do is, what does P of 3 mean? Okay, let's see. This is saying, George the slug on steroids, I have no idea why it has to be a slug, nor does it have to be on steroids, but whatever, is running back and forth along my porch. I'm watching him, and why did you name your slug George? Whatever. This thing's weird. All right. I'm watching him run back and forth, and the graph below depicts his position in feet to the right of my door in T seconds that I began watching him. So, if you look at the graph, and it looks like this, what does P parentheses 3 actually mean? Interpret that for me. I'm just going to write down P3, and you tell me what that actually means.
P of 3? I don't know.
It means P of 3, so what is that?
Position of 3?
It means position of, what is the...
3 feet.
it's supposed to be p of t. That's what it normally is. Time.
So seconds.
So it's saying this is your position
At 3 seconds.
at 3 seconds. So 3 seconds after you've started watching the slug run back and forth, it's telling you the position. So this is going to be something like, well, actually, let's figure out what it is. What is p of 3? It's 0, exactly. Because look, it's your seconds was 3, and so what is your p as a function of 3? What is the height that it's at when it's at x equals 3, or t equals 3 in this case?
0.
It's 0. There we go. Do you guys see that? Do you guys, does this make sense? What is p of 0?
3.
P of 0 is 3, is equal to 3. So p of 0 is, and what does p of 0 represent?
The distance?
The distance at what time? The distance that he started at what time?
0.
At 0 seconds, exactly. At 0 seconds, so this variable in here tells you the time that you're looking at specifically. This tells you for any general time, whereas this tells you a very specific time. This is saying at 0 seconds, this thing, the snail started 3 feet away from the door, or something like that.
Okay.
Does that make sense?
Yeah.
And then I watched the snail, and at 1 second, the snail was exactly at my door. And then I kept watching the snail, and apparently at 3 seconds, he was at my door again. But at 0 seconds, he started 3 feet away from the door.
Right.
Does that make sense?
Right.
Are we able to kind of read this interpret this magic code? It's not really a code. It's not really magic, but I mean, all right, let's see. What would this represent? All right, here we go. Let's do this. Tony is thinking about starting a company that makes special pencils. Yes, pencils. Not usually very exciting, but these are see-through pencils with rainbow-colored lead inside. Okay, all right. Let P of X represent profit in dollars. Can Tony, that Tony can expect by producing X batches of pencils. A batch consists of 1,000 pencils. So what is P of 3 in this context?
How much he makes?
It makes how much he makes if he made how many pencils?
1,000. Oh, right. No. Yeah, 10,000 pencils.
30,000 pencils. Because this is P of 3 batches, and a batch is 10,000 pencils, so it'd be...
Oh, 30,000.
If he made 30,000 pencils, this is how much money he would make.
Okay.
Does that make sense?
Yeah.
All right. What... Describe the following quantities. What is P of X plus 3?
How much he sold?
No. This one's a little bit tougher to kind of wrap your head around. Okay, what is P of X?
The profit?
That's how much profit you made, right? What is P of X plus 3? Well, let me describe it to you, and hopefully describing it well. I'll say, hey, look, I know that you can make X amount, or I know that you can make P of X amount of dollars if you sell X. But if you made 30,000 more pencils beyond what you were planning to make initially, this is now how much money you make. That's the words that I'm saying.
Right.
That is what this is saying in words. This is the profit you would make if you make 30,000 more pencils than what you were originally going to make.
Oh, okay.
And then what were you originally going to make? I don't know. You didn't tell me what you were originally going to make, so I represented that with an X. Does that make sense? Because P of X alone is what you were originally going to make. P of X plus 3 is what you were originally going to make, plus if you made an extra 30,000 pencils.
Right.
Are we cool with that?
Yeah.
All right.
So same thing with the P of X minus 2.
Yeah. P of X minus 2 would be
taking away.
Here's how much profit you would make if you made 20,000 less pencils than what you originally were going to make.
Okay.
So I mean, math is actually nice because what happens is I can describe this. I can just write down p of x minus 2, and there's this whole sentence that it actually describes. You know what I mean? And I think that's pretty awesome that it describes all of these things, but really it's just, it's pretty straightforward. This is what it is. We cool with that?
Yeah.
All right. What about p of x plus 3 minus p of x? This part D. What is that in context? Describe it.
You make 30,000 more than your original. I don't know.
And then you're selling it to someone? I don't know.
This is saying this is your profit if you made 30,000 pencils more.
Right.
Minus the original profit that you would have made.
Okay.
So you want to know what this answer is? I think this answer is p of 3. This is the profit you would have made if you made 30,000 pencils.
Oh, yeah.
Because you're taking the original and you're adding 30,000 pencils, and then you're subtracting off your original.
So same. Yeah.
So it's
Yeah.
P of 3.
So it's really just p of 3. That's what I think it is.
Yeah.
This is your profit at 30,000 pencils. Are we cool with that?
Mm-hmm.
All right, let's see. We could. I don't think I'm going to go there with you. Yeah, I guess I could. I mean, it's not that bad. We could apply this to an equation because right now I didn't tell you what the equation was that described our profit. I just
It
told
was
you
just
that it was
sentence.
just. Oh, what is that?
A sentence.
It was just a sentence, right? But we could actually use this. What if p of x in this case was negative 1/2? What is it? Negative 1/2 x squared plus 5x minus 8. Actually, this looks familiar to me. Oh, it's the thing up there. It's the same one. Okay, all right. P of 3. What is P of 3? P of 3 is, normally it's P of x, but this time I'm making it P of 3, so it's indicating to me that I am replacing any x with a number
3.
with a number 3. So I should just write down my equation with the number 3 instead of an x.
Yeah.
So it'd be negative 1/2 3
3.
squared plus 5 times 3 minus 8. So that would be half of 9 plus 15 minus 8. Let's see. Brad's really good at math really quickly. That would be like 4.5. So that would be 19.5. So that's like 11.5, I think. 19.5 minus... Or is it 12.5? One of those. Anyway, you get a number. Blah, blah, blah. That's your answer.
Okay.
Now I'm curious. Hold on 1 second. 19 minus 8 is 11. Right? Yes. All right. All right, good. Yeah. Yeah, 19. Yeah, it's 11.5. I was right. Okay, good. All right. So check this out. What about p of x plus 3? That one's a little weird. P of x plus 3. How do I deal with that? All right. When I had a 3 in there, I wrote down my original equation, but I replaced all the x's with the number
3.
If I had a 4 in there, I would replace all my equations with the number
4.
If I had a happy face in there, I would replace all my
Happy face.
x's with the number, well, not a number, but with the symbol
Face.
happy face. In this case, I have p of x plus 3. I'm going to replace all the x's with n
Plus
x
3.
plus 3.
Right.
So this would be negative 1/2 x plus 3 squared plus 5 times x plus 3 minus 8.
Okay.
It's not, I mean, it looks confusing. It looks horrible. It's not really that bad.
It's not.
All right. I mean, I guess I could solve this out for you if you wanted to. This would be negative 1/2 x plus 3 squared. Isn't that like x squared plus 9?
Yeah. But when she... Oh.
Bradley says no, and good, because Bradley's the only one in this room right now who doesn't deserve a boot to the face.
I was going to say, if, like, you squared it, then x2 would be gone.
This is actually what it is. It's x squared plus 6x plus 9.
Oh yeah, that makes sense too.
Yeah, if you don't believe me, foil it up for yourself. I think I remember. I think that I remember even specifically saying I would put my dirty foot in your face, like literally my toes on your nose and my heel on your lips, if you told me that x plus 3 quantity squared is equal to x squared plus 9. Or I didn't say specifically x plus 3, but I said something like that. Whereas like a plus b is equal to a squared plus b squared. No, that's wrong. You're missing all the cross terms, and that's what we end up coming up with. All right. Plus 5x plus 15 minus 8. So this would be 1/2 x squared plus 3x plus 9/2 plus 5x plus 15 minus 8. And then this would be negative 1/2 x squared plus 8x plus 11.5. Anyone confused with what I did?
A little. With
All I did,
this.
all the rest of it is. Oh wait, you don't understand this part, right?
Yeah.
All right, fine, I'll do it.
Like, how did you get it like that?
Okay, all right, I'll do that part for you right now. X plus 3 squared is the same as x plus 3 times x plus 3.
Okay.
That you cannot argue with.
Yeah.
Then you FOIL that. So first is x squared, outers is plus 3x, inners is plus 3x, and last is plus 9.
Oh.
Combine the like terms, x squared plus 6x plus 9. That's where I got that.
Okay, that makes sense.
You'll get good at it after a while.
Yeah.
All right, so this is p of x plus 3. This is the profit. This is the equation for the profit you would make if you sold 30,000 more pencils than you were originally going to plan to sell.
Mm-hmm.
So tell me, how much were you originally going to plan to sell or to make? Give me a number.
30,000?
Well, let's choose a different number than 3, just because that would be
40.
40. You were planning on making 40,000 pencils, or 4 batches of pencils.
Mm-hmm.
So you would plug a 4 into here, and I would say, well, if you plug 4 into this equation over here that I boxed, this tells you how much money you would make if you made 70,000 pencils, if you made 30,000 more than what you originally planning. And all you do is you plug in a 4 into here, 4 into here, and you just calculate it out, and that's how much money you would make. Mm-hmm. Bada bing, bada boom, done.
Okay.
We cool?
Mm-hmm.
All right. And then this p of x plus 3 minus p of x, well, this is p of x plus 3, negative 1/2 x squared plus 8x plus 11.5. And minus p of x, what was p of x? P of x was this thing right here, right? So that's minus 1/2. Is it negative? Yeah, it's negative 1/2. Minus negative 1/2 x squared plus 5x minus 8. I think that's what it originally was. I'm just plugging in that.
Okay.
And then I say, all right, so this is negative 1/2 x squared plus 8x plus 11.5 plus 1/2 x squared minus 5x minus, or plus 8. I don't need that plus in there. 8. Do you understand what I did?
Mm-hmm.
Okay, let me just double check to make sure that I know what I'm doing. Yeah, this looks good. All right, good. Now, this cancels out with that, because I have negative 1/2 x squared and positive 1/2 x squared.
Mm-hmm.
I have a 3x, and I have a 11 plus 8 is 19.5. Huh. Something looks a little funky to me, but apparently this is what this answer is right here. It looks a little funny to me, and I might have made a mistake. I'll have to check that later, but basically all you do is plug in the things into your equation that you're looking for.
Right.
Are we cool with that? I'll come back to it and take a look. Something's a little like not sticking well with me on that particular problem.
Sophia says you can solve that.
But I can solve that. Solve that for what? What are you talking about?
Three x plus 19.5 equals 0.
That's true. You could solve that, but the problem is, Sophia, nothing told me that I wanted it to equal 0. In fact, to be honest with you, I don't want it to equal 0. Absolutely do not want it to equal 0. Would you like to know why? Because this is describing my profit.
So
I don't want my profit to be equal to 0. No, not negative. I definitely don't want it to be negative. That means I've spent more money than I made. But I don't want it to be 0. That means I just broke even. That's not fun either. Because you didn't really break it even. You just kind of put all your money in there. Anyway, I'll take a look at it again. I think that there's something that's kind of funky to me about it, but I'll come back to that. All right, let's take a look at this one. Average rate of change. They're going to give you some kind of funky equation right here. F of B minus F of A divided by B minus A. Okay?
Right.
Would you like to know what this equation is?
Distance formula?
It's a slope.
Oh, yeah, that.
Because F, let's change this to a 1 and a 2.
Okay.
1 being A and B being 2. This is saying F of 2 minus F of 1 over...
2 minus 1.
Well,
2 minus 1.
let's change... Let's let A equal to x1 and B equal to x2. Okay? So this is saying F of x2 minus F of x1 divided by x2 minus x1. Are we cool with that?
Mm-hmm.
And wait, F of x2, isn't that saying that's the y value whenever x is equal to 2? That's the y value at point 2.
Mm-hmm.
So can't I just change that to y2 minus y1
Yeah.
over x2 minus x1?
Yeah.
That's the slope.
Same thing.
Yes, it's a slope. That's it. And you guys are wondering, wait, why is he reteaching us slope? That I got. I got slope really well. Here's the thing. We're now going to apply this to curves.
Okay.
So like our original equation was like that. And we want to find what is the average rate of change between this point and that point. What's the slope of this curve? Now you're thinking to yourself, well, what the heck are you talking about? There is no slope to a curve. A slope is between a line, 2 points on a line. Can you open the door? It's hot. All right. A slope is between 2 points on a line. What is he talking about with a slope of a curve? Does that make sense?
Yeah.
So you guys are wondering, like, wait a second, where is he going with this? Well, I'm not talking about the slope of the curve, but what I am talking about is the slope of these 2 points that are on this curve. Does that make sense to you?
Yeah.
All right. So that's all they're asking you to do when they're saying find the rate of change of something. All you have to do is find, like, let's see, do they give us an equation? They don't give us an equation, but we can even do a problem like this. Like, if our original equation was P of x is equal to negative 1/2 x squared plus 5x minus 8, that's the original equation that we started off with, right? That we've been working with this whole time. And I wanted to find the average rate of change between x equals 3 and x equals 4. Then what I would do is I would say, okay, well, what is P of 4? I'd plug in 4 into this thing and I'd calculate out that number, whatever it is.
Mm-hmm.
Then I'd say, what is P of 3? I'd plug in 3 into this thing and calculate out what that number is. Are we cool?
Mm-hmm.
And then I would say, okay, well, it's just P of 4 minus P of 3 divided by 4 minus 3. That's your average rate of change. It's the rate of change between here and some other point here. Are we cool with that?
Mm-hmm.
Now, Sophia's actually really excited because she was like, dude, all you've been covering for this entire time has been review for me. That's what Sophia's told me before. Oh, I'm sorry, Bradley, where did I get the 3 and 4? I just made it up. I said, say that we want to find the average rate of change between the numbers x equals 3 and x equals 4. I just made up that in a problem. Are we cool with that? All right. Now, Sophia's actually really excited because now we're finally covering things that she hasn't covered yet. And so she's told me, hey, now I'm finally looking at something that I haven't seen before. But I feel like you've seen this before, right? Have you guys seen this before?
Yeah.
But it's not really that crazy.
No.
And you guys are even wondering, why isn't he assigning any homework on this? This seems like pretty easy stuff. Okay, let me show you something that will blow your mind. I think this will blow your mind. And this, to me, is where we get this stuff. And this, is to me, is where you're going to get really excited about this stuff. Please look at this equation and kind of keep it in the back of your brain, especially when you get into this class called calculus. And you guys are thinking, oh gosh, calculus, that's so hard. Yeah, it is hard. It's not an easy course. It's one of the highest math courses you can take in high school. And so why is he talking about calculus? Well, let me tell you this. Because in calculus, one of the first quarter of calculus is going to be spent finding this thing called the derivative of something. Okay? And what you're going to do is, when you find the derivative of something, is you want to find the slope of a line that is tangent to a curve.
Okay.
Do you know what the word tangent means? The word tangent means touching only at one point of the curve. So it's almost like if I were to have like a board and I were to balance on this thing, the board would be at that angle like that. Does that make sense?
Yeah.
Now here's the problem. How do you find the slope? So it's touching only at one point.
Mm-hmm.
Got it? Here's the problem. How do you find the slope of a line that is going through one point? We've covered this idea before. If I have a point, Sierra, sorry,
It's okay.
draw for me a line that goes through that point.
On the
This
screen.
particular point, right there. On the screen. Go for it. It has to be the line that I'm thinking about in my head. Go for it. Draw it.
You want what again?
I want a line that's going through that point, but it's got to be the one that I'm thinking about. Oh, that's terrible. That was wrong. I was actually thinking about this point.
Oh.
That line.
Oh well.
No. Do you get my point? Do you get what I'm trying to get at here?
Yeah.
What am I trying to get at here?
That it touches one point.
No. That it's impossible to do what I asked. If I ask you, draw a line that goes through this point, and it has to be the specific line that I am thinking of, is it even possible to do that? I mean, you might get lucky, but it's pretty impossible, right?
Right.
Because how many points do you need to describe a line?
2.
You need 2 points.
Oh, okay.
If I gave you the task, Ciara, draw me a line that goes through those 2 points, and it has to be the line that I'm thinking of. Well, the line that you draw is, I mean, if it actually does go through the 2 points, you've learned how to connect the dots, back in kindergarten.
Yeah.
If it actually does fit the criteria, then it has to be the one that I was thinking of in the first place, right? By the way, we're going into kind of a tangent here. Actually, hey, that's a good play on words because we're talking about the tangent. What we're doing in calculus is we want to figure out the slope of a tangent line. But I hate to say it, it's impossible because we only know, because we're talking, you're asking me to find the slope of something that only touches at one point. How do I know what angle it is? You see what I mean?
Right.
So here's the trick that we do. All right, and I'm saying keep this in mind for calculus when you take it. Is we say, all right, fine. What is the average rate of change between, if this were a graph, and this were point A and point B? Let's make it this is point A. Sorry.
Sophia says you can't touch any other points on the curve.
Sophia, that's almost correct. All right, here we go. Okay, let me just erase this real quick. All right, so this is point A, and this is point B. And I want to find the average rate of change between these 2 points that you gave me. So, let's see. Dot, 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 dot. I'm going to draw a horizontal, dot, dot, dot. I'm going to draw a horizontal, dot, 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 like that. This would be f of A, and this would be f of B. Do you guys see what I'm saying here?
Yeah.
And then this point right here, this is A. So I can find the average rate of change between these 2 points right here,
Okay.
right?
Right.
Using this equation. F of B minus F of A over B minus A. And all that is it's the slope equation.
Right.
Right?
It's just
It's
replaced.
it's not even complicated calculus or
Yeah.
math. That's a slope equation. You're just replacing x1 and x2 with B and A.
Right.
Okay. Then what we do is this. Here's the tricky part. Is we said we want to make this red line. See this red tangent line right here? It's not really a tangent line because it's going through 2 points. We want to make it look like the black line. So here's what I do. What if I imagine that this black curve was like a wire, okay? And imagine if these 2 points were like beads on that wire. And I took super glue and I glued down this bead over here, right here, this one right here. Glued it down. And then I took this wire right here and I put it in my fingers and I moved it closer to the other dot, closer to the one that's glued down. What happens is this point gets closer here, and then that red line now comes like that, right? And then what happens if I even move it even closer, like right there? Then the red line starts to look very similar to the black line.
Right.
What if I move it so close that I can barely see the difference between the two of them? Then the red line pretty much becomes the black line. Basically, right? That I just described for you. Quarter 1 of calculus. That is what you're going to do. I kid you not. That is how to take a derivative. That is what you do.
You just
Have fun with that. It really isn't. I mean, it really, when you take a step back and you really look at what you're doing, that is exactly what you're doing. I just described to you what we're going to do in calculus. And I think that's maybe why they introduced it to you now, but I feel like it's not really relevant in your Algebra 2 curriculum, although I can see why they want me to introduce it to you, so that way when they introduce it to you in calculus, it's not complete magic. They don't pull it out of their butt and throw it up on the board and say, hey, remember this? And you'd be like, no, I've never seen that before. But anyway, there you go, Sophia. Calculus for you to stimulate your brain. That's what you do. Does that kind of make sense to you?
yeah.
And technically, we are still finding the slope of 2 points. Those 2 points just happen to be very, very close together. So close that they actually look like 1 point. In fact, what we say is we call this distance between these 2 points right here, we usually call that h. I don't know why they use an h, but they do in calculus. And then we say we want to take the limit as h goes to 0. Well, the limit as h goes to 0, the limit as h gets smaller and smaller and smaller. If h gets to 0, basically you're saying when a equals b, right?
Right.
The limit that a is getting closer and closer and closer to b because the distance is getting smaller and smaller and smaller. That's calculus. There we go. I almost, there's only a few more steps and I can actually show you what the fundamental theorem of calculus is. but I'm not going to because we're going to move on. Cool? All right. Interesting to you or just completely like, I knew that. Although that's easy for me. Actually, it wasn't. It was easy. I think it was easy.
It was easy, but you just went into a whole